Okay, so the next problem we are solving in Leet code is the 88 one merge sorted array. Okay, so we'll be given the two arrays nums1 and nums2, and we'll have to, and also it has been mentioned that both are sorted already. Okay, and we'll have to merge it, and again the final array what we get should also be in a sorted order. Okay, and also we have given the number of valid elements that are present in the nums1 nums2 we can see that there are three elements, right? 2 5 6. This is okay. And now, okay, before actually coming to this, right, why nums has 6 element but m is equal to 3, let's try to understand this. Okay, so basically here we have been given the two arrays, right? We'll have to merge it and we'll have to give the final result. Okay, so ideally what we can do is we can set our pointer here and here, we can compare, we can create a new list, right? We can create a new list and do the comparison. Whichever is less, I will push that element to the list. One is less, I will move to the, I will move that element, right? I can set one, and then again I will compare between these two. Any one of the element can move. So two will come here, and again I can do this comparison. 3 and 2, 2 is less. I will do this, and again I will compare between 3 and 5. 3 will come, and again there is nothing left next, right? So it will be 5 comma 6. I can create a new list out of it, correct? I can create a new list and do this thing, but the restriction here is we'll have to make sure to update the same array. We are not supposed to return anything. We'll have to update the same array. So what we are going to do is, for that case, it has been given that it has been handled that there are some empty spaces already available in the nums1. Okay, so that these elements fit in there, right? So that's why there are some extra spaces, and that's why m is equal to 3 and n is equal to 3. These are the valid numbers and those are the lengths. Okay, so now how to solve it, right? So what one thing we can do is, initially what I had done was, like I created a copy of it. Like, I mean, basically now, right, we need to iterate through, correct? We need to iterate through, and also we'll have to update the same nums1, correct? When I do the comparison, I will have to replace this with 1 and 2. One is less than 2, right? Let's say that I have to update this, correct? And also 2 is also, it will be the same. Let's leave it as it is. And here, right, we'll have to, when we do the comparison between 3 and 2, 2 is less. I will have to overwrite this value with the 2, and I will be losing the value 3, correct? So what I had done was I had taken a copy of it and then do the comparison, and based on that comparison I was updating this. Okay, so that will lead to, like, as we are building the copy of this nums1, right, it will increase the time memory complexity. Like, I mean, the time complexity wise it was almost the same, but it does increase the memory complexity as we're making the copy of it. Okay, so that was one case. So now how to go about it, right? So instead of starting from the, let's say that instead of copying this whole array separately and doing it, so what we can do is we can, so that it means that if we start from the beginning, right, obviously we'll be losing our progress. Like, I mean, we'll be losing some values. So instead what we can do is we have some empty spaces left here, right? So we'll start doing the action from here. Okay, so what we'll do now is we'll set our pointers to, like, I mean, we know that m is pointer here, right? We'll be setting our one pointer here, and the last merged one will point it here. Okay, we'll do the comparison from between these two wherever there's m and n pointing, right? We'll do the comparison for these two, index 1 and index 2, and whichever is greater we'll place it at the end. So that's how we'll place the 6, right? 6, we'll place the 6, and then we'll decrement our pointer to here, and then do the comparison. 5 is greater, we'll place it here, and then do the, again we'll decrement here, we'll do the comparison. 3, we'll place it here. Okay, and once we are done with this, right, we have placed our 256, correct? 256 is placed here actually. So it would be like 2 here, 5 here, 6, correct? And 3 got moved here, but that's fine. And now we are done with processing the second array, correct? Once we are done with processing the second array, it means that as we know, we don't have to, like, I mean, we can stop there, correct? We can stop there because 1 2 is already sorted. We don't have to run the loop again and modify anything. We are good here, correct? So okay, now this is the logic. We'll be doing it from the back side. So let's check the code. Okay, this is the code I was using it for copying. Okay, I copied it and then do the comparison, and I was updating the old one. Okay, nums1. So here, right, so whatever we discussed so far, right, we'll be setting the two index for nums1, nums2, and whatever the merged index one. Okay, and here we'll be doing the calculation. If either both of them should be there, right, both of the content should be there to compare, to do the comparison. If both is there, we will then check whichever is greater. We will update the merged value to the end of the list. end of the list or wherever the merged index is pointing to. Once we update, we need to make sure that we'll be decrementing our merged index, and we'll have to correspondingly update the index 1 and index 2. Okay, and finally, let's say that if there is only nums 2 left, let's say that if there is any element left in nums 2, right, only then we'll have to run this loop. Okay, and we can run this loop for index 1 greater than or equal to 0, but it doesn't make sense actually, because there are elements already placed, right? We don't have to run a loop for index 1 and update it again and again, right? We don't have to do that. So let's see, like, why I'm telling that is, let's say that 4 5 6, right? After we run our first loop, what how it will look, this is 4 5 and 6. So this is current incorrect, actually this would be 2 3. Okay, initial array was wrong. Okay, and we'll place our 4 5 6 to here. Okay, and now as we're done with nums 2, we don't have to run this, right? Because this is already sorted. So that's why we have only one loop there at the end. Yeah, that's it. Thank you.